Hi, my name is Muhammad Shahid Munir, and I am going to present the topic of art of camouflage, raising an acceptable memory from diffusion model with the adversarial eyes. I am presenting this topic for data driven security and privacy subject by Professor Simon Wu. So, this presentation might contain some unsafe language and imagery that might be highly offensive to some readers, such as this might contain some profanity, vulgarity or something, but these are only included for the purpose of education and for the purpose of raising awareness about the misuse of AI text to image models and to devise a safety mechanism for that. So the presentation slides will contain introduction, methodology, experiment, and conclusion, future work, and to talk about text to image models. Text to image models are models that generate images using text or either both text and images, and the images are highly realistic and it is harder to distinguish, but they have a lot of real world benefits, such as they can be used in marketing, but along with good use there is a negative use associated with that, and that negative use is to generate one negative use could be to generate sensitive documents, sensitive images by using sensitive or NSFW uh, prompts. So these prompts can be highly unwanted in a safe world scenario, safe web scenario. So AI image generation started with generative adversarial networks that generated images that were highly realistic and unable to distinguish. So Stable Diffusion fueled that AI image generation by offering more realistic and better images, and content generated with Stable Diffusion can also contain unacceptable images. Prompt filter and post hoc security filter are employed to safeguard Stable Diffusion, but they can be surpassed easily using adversarial attacks on multimodalities, like not only text, but it can adversarial attack can be also made on image as well. So in this paper, we have presented a large-scale multimodal text and image profanity dataset that is called NSFW corpus, which not only contains real samples generated using diffusion models, but also contains NSFW images and text samples with adversarial examples that can be used for training. So we propose a multimodal defense as well that works for T2I and I2I models to guard them against profanity and adversarial attacks. An unlearning approach is also explored in correction correlation with multimodal defense. The extensive experiment shows that the model performs very well. So we start by collecting and generating dataset, and after generating and collecting dataset, we proposed model is trained and experimented on different cross datasets, and we also test an unlearning approach. So the dataset pipeline is shown where we have used NSFW vocabulary pairs and then generate a sentence to form as a prompt for the large language model. The large language model created another prompt that is fed it to the Stable Diffusion Lightning. The resulted image and text is projected to a perturbation and to an attack algorithm that generates perturbations, that generates an adversarial example for both text and images are separate, and then we use in section B we use NSFW sentences that are sourced from online and Reddit, and then these sentences are also used to generate images using the Excel Turbo text to image model, and all of these collections are so saved in our dataset. So, talking about the composition, the dataset consists upon the real samples and fake samples, safe samples and unsafe samples. Real or safe samples are around 100K, 500K, and the total NSFW images are around 500K. So total is around 1 million. So as shown in previous slide, we scrapped prompts from online sources and generated large scale using large language model. So the pipeline is already discussed. So let's discuss the text to image um, existing model of defense mechanism. Let's say there is an NSFW prompt that is filtered that in current traditional prompt filters is filtered directly without generation of the text or of the image, and if the prompt contains an unsaf or NSFW content, it is considered as unsafe and user is blocked to generate an image. If the resultant image here generates is generated as a post as a NSFW, it is unsafe, then the black image is returned, otherwise a safe image is returned. So in our approach we propose a joint classifier, joint uh, defense system where both target and SFW image and SFW prompt are jointly classified into real safe or unsafe, and the safe feed is feed forward to the stable diffusion, otherwise it is blocked. Similarly, in the text to image scenario, an SFW prompt is feed forward to the stable diffusion if the image is feed forward to the image encoder, and an SW prompt is forwarded to the text encoder. The class joint classifier tells whether it is safe or unsafe. If it's unsafe, then we restrict the user, otherwise we let it go. So this is the proposed approach for joint learning, and the proposed approach consists upon an encoder, vision encoder, and text encoder. The joint transformer network uh, learns to discriminate between real and fake and the linear projection, then predicts token, and then we have a linear classifier to tell whether it is safe or unsafe. So discriminator we already discussed, and this is the unlearning mechanism where the discriminator will be used as a penalty, as a discrimination loss, to update the loss such that the model discourages the diffusion model to generate any unsafe or NSW as an NSFW image. So this is the loss function that we talked about earlier. Experiments. The experiments show a very good trend here. We got a little bit of very good of performance improvement here. Similarly, we see a lot of drop in attack success rate in our model that you can see is lower than all other models. And the generated image from us after unlearning does not contain any nudity, if even if the prompt has nudity. Experiments, as we discussed earlier, and the conclusions say that we have successfully created a joint learnings multimodal defense mechanism in this paper, and we have proposed a dataset that has too many images and image and text pairs, and secondly the discriminator network can be used to unlearn. Next future work would be to increase the unlearning capability to learn more, to use device more better method for unlearning. And since we have discriminator network that will be uh, that is made online and you can use it, and the I am